Okay, so this video is going to be our Algebra 2 Unit 3 to 10 video, the second of two. So this is the last of the two videos. And in it, we're going to basically discuss EQ3 here, finding linear or quadratic factors using grouping, right? And mostly we're going to just deal with linear factors, but we'll get to that. So this first example here, we're not going to follow what all these directions say. We're just going to talk about how we can use factoring to get linear or quadratic factors, right? So we notice there's one, two, three terms here, all of which have x minus 3 in common, right? So that means we can treat that as a GCF. We can treat that as a GCF and go ahead and factor that out. So once I factor out x minus 3 from all of these, okay, what am I left with? Well, I'm left with x squared plus 2x minus 3. So x squared plus 2x minus 3. Okay, that can be factored further, this right here, just using just basic fill in the blank. So this can be x plus or minus something times x plus or minus something else because a is equal to 1. So what are the factors of negative 3 that will combine to give me positive 2, right? And quite simply, that's going to be positive 3 and negative 1. And then we have x minus 3 here. So now I have factored f of x, which was a third degree polynomial, right? So if this is second degree here times another x, that would give me x to the third, right? Or if we look at it, I have 1, 2, 3 linear factors. And of course, x times x is going to give me x to the third. Either way, right, it's going to be a third degree polynomial. So it's going to have 3 roots or intercepts, right? So that means it's going to have x-intercepts at positive 3 for this one, negative 3 for this one, and at positive 1 for this one. Okay? And if I decided to chuck this into the calculator, which I'm going to, let's see, let me do control delete, yes. Okay, so I'm going to throw it in its factored form. Let's move this over here. Okay, so I've got x minus 3. So open parentheses, x minus 3. Open parentheses again, x plus 3. And x minus 1. X minus 1. Okay, so I'm going to delete all this stuff that was on here from before. I don't know what all this nonsense is. Anyway, the point is, we see we've got zeros all right here. Okay, and guess where those points happen? If I go ahead and change my window zoom to standard, it's pretty obvious this happens at negative 3, positive 1, and positive 3. Negative 3, positive 1, and positive 3. Okay, so pretty useful stuff, right? So because I was able to factor it, I can easily see what the x-intercepts were of something that wasn't a quadratic. It used to be that we could only do that with quadratics, and it was very difficult to do otherwise, right? So let's practice on a few more examples. Not going to look at the graphing for this. All we're going to do is practice factoring, right? So factor h using grouping, okay? And I can do so just by kind of rearranging the terms, right? So 3x to the fourth, 9x to the third, both have a 3x to the third at least in common, right? So when I factor that out, that's going to leave me with x plus 3. Okay, then I look here. So this plus 4x plus 12, they both have at least a 4 in common, right? So then that means I'm going to have a plus 4, leaving me with an x plus 3 again. Then we see, well, we have an x plus 3 we can factor out, much like what happened over here, right? Factor out the x plus 3, and that leaves me with 3x to the third plus 4, right? So now it is factored. So now I've got h of x in a much simpler form. And from this, we can also see what our x-intercepts would be whenever I set this guy equal to 0. Okay? So pretty cool stuff. Let's do another one. So factor m using grouping. Okay, so this one is going to work out pretty much the same. Okay, this one's going to work out pretty much the same. I can just group right here, luckily, right? It's not going to always work out this way. Okay, but if there's a chance for you to do this with grouping, then by all means, let's do that. So on the left, right here, I can factor out 2x to the third, right? So I can factor out at least a 2x squared. Whoops, I still put a third. I can factor out a 2x squared. Okay, so that's going to leave me with x plus 5. Okay, and then over here, I can factor out a negative 3, and that's going to leave me with x minus, plus 5. Okay, and then we see we've got matching factors here and here again. I can factor those out. X plus 5, leaving me with 2x squared minus 3, right, is equal to m of x also. Okay, and I can easily calculate my x-intercepts here. They would be 3 over 2 would be a double root, and then the other one would be negative 5. We'll talk about double roots and things later. Okay, last one for this video. Hopefully I'm not running this video too long. Okay, so now we are going to have to do some rearranging. Okay, so they're not conveniently going to factor out the way we need, right? Or actually, they still could, but I just want to prove a point on this one. Okay, so we're looking here at n of x. Okay, so I'm going to rearrange. I'm going to put the 4's together. So 4x to the 4th plus 4x. And then I'm going to put the plus 7x to the 3rd, put the 7's together, right? And this may work out nicely. I don't know. Let's see. So I'm going to factor out from here, I'm going to factor out 4x. That's going to leave me with x to the 3rd plus 1. And then here, I'm going to factor out just a plus 7. That's going to leave me with x to the 3rd plus 1. Okay, so even if I hadn't moved them around, it actually still would have worked out that way, right? But either way, we have a common factor of x to the 3rd plus 1, which is exactly what I'm going to factor out, leaving me with 4x plus 7. And that would be another way of expressing n of x. Okay, and we can easily see one of our roots would be negative 7 over 4, and then we would have a triple root of negative 1. Okay, so that's going to do it for this video. Like always, shoot me an email if you need anything. Otherwise, you know where to find me. Goodbye.